In this video, we're going to simplify some radical expressions. We got 4. And we're going to assume that all variables are positive whenever they appear. That way you won't have to use any absolute values if you have a even power, even root, I should say, fourth root, square root, and so on. And of course we want these in simplest form. So the first one has the fourth root of 16. Now if you know the simplified form just by looking at this and write it out. If not, you can think of this as 16 is 2 to the 4th. The 4's cancel out. 4 into 4, so this comes out to 2. 2 to the 4th, it does give me 16. The next one we have a cube root. And the best thing to do this is to go ahead and simplify the radicand. So notice you have an x in the numerator, x to the 4th in the denominator, y squared and a y squared. So do some cancellation there. So the y squared divides out. And this is the cube root here. 3 goes into 81 27 times. So 3 into 3 is 1, and 3 into 81 is 27. This will be a 1 here. And we got x here, and x to the 4th. That reduces down to 1 over x to the 3rd. This will be x to the 3rd here. Now we can just go ahead and simplify. Got a cube root of a fraction. That's the same thing as the cube root of the numerator over the cube root of the denominator. Of course, the cube root of 1 is 1. The cube root of 27 is 3. 3 to the 3rd is 27, and the cube root of x to the 3rd, of course, is x. So this simplifies to 1 over 3x. 1 over 3x. Now the next one doesn't have any variables. Here we're just multiplying here. So you can treat this like a regular binomial, 2 terms here. So you can say the first terms multiply each other. So the square root of 5 times the square root of 5 is the square root of 25, so that would be 5. And then a negative 2 times a 3, that's a negative, or minus 6. And then these two multiply each other, these two multiply each other here, and then you add them up. So that gives me 3 radical 5, and a minus 2 radical 5 gives me a minus radical 5. Or I should say a plus radical 5. Minus 2 radical 5 and a 3 radical 5 gives me 1 radical 5. And then 5 minus 6 is minus 1. So this comes out to the square root of 5. 5 minus 6 is minus 1. That's in simplified form. And we simply mean in simplified form, of course, you have to have the radical in the simplest form. It's a square. If it's a square root, you don't want any square powers in the radicand. If it involves a fraction, you want it in simplified form. That's the answer to that one. So now let's do this one. Give some more room here. So here we have the cube root of 16. We have x to the 4th. So let's look at these. We're looking for cube roots. So 16, I write that as 8 times 2. 2 times 8 is 16. And 8 is a cube root because the cube root of 8 is 2. So leave it that way. Of course, x to the 4th does have a factor, a cube factor involved there. Got x to the 3rd here and x. And of course the y is 1 to the 1st, so we leave it the way it is. So now let's see. 8 is a cube root. Let's take the cube root of 8. That comes outside the cube. We get 8. And we got x to the 3rd. The cube root of x to the 3rd is x. So the 2x comes outside. And then anything else that's not a cube power, or doesn't have a cube root, stays. So the 2 will stay, and the x will stay. So that part is in simplified form. Now let's look at this one over here. Got a cube root here, but I don't have any perfect cube factors in this radicand. So that's going to stay the way it is. So it'll be minus 3x, and that's going to be the cube root of 2xy. And then on the first one on this problem here, I got the y here. So I took the cube root of x to the third. That goes out, that's outside. The x stayed, but I still have the y here. I get that. And then over here, this is y to the third here, times y. Got a cube root here, so this negative can come out here. So this will be a minus, and then a 5. And the cube root of y to the third is y. And this used to be the cube root. Took out the negative, but the 2 stayed. The x stayed. And of course, the y stayed. The cube root of y to the third was y. So that came out of here. So now these two are common. Notice this one here has cube root of 2xy. This one has the cube root of xy. And of course, the coefficients are like terms, x and x, so we can just compute these. A minus 3x and a 2x is a minus x. And then this just be the cube root of 2xy. And then this comes along. Notice this is different here, because this has x's in front, this has a y. So that one I have to leave it as a minus 5y. This would be the cube root of 2xy. Now this could be given as your answer right here. If they say you to factor it, notice here we have a common term, cube root of 2xy. So we could factor that out, and this could be left as minus x minus 5y. Put this in parentheses. So took out the cube root of 2xy. So I'm left in front minus x minus 5y, and this is times cube root of 2xy. And we could get this if they tell you they want it in factored form. But either one of these is really the correct answer. It's in simplified form. Thanks for watching. We'll see you next time.